Hey everybody. All right, we're in section 7.4, which is applying the properties of similar triangles. And so there's some proportionality stuff in this section that we're going to go through, and a few different properties. So there's one on this slide, there's one on this slide, and there's one on this slide. And I think that's it. So there's three different properties that we're going to do. So you could skip ahead. You could go look, if you're following along with your book by chance, you can look at some of them in there. I've included examples on each one. So if you do an example and you feel like you're set, kind of skip ahead and move on. And if not, you can see the examples done out. So I'll do an example after each property and show you exactly how you apply these. I was told that I need to be funnier, but it's a little hard in an empty room. So I'll try to insert humor as necessary. But we'll do our best here. So I got to create a name for this triangle. So I don't know what you want to call it. I don't know. We can name it after Lindsay, since she's the one who gave me a hard time. So we'll label these parts in these triangles. So if you have a line that's parallel to another side of a triangle, it's going to split it up proportionally. And this is kind of similar to one of the properties in 7.3. But I'll write it out so you know what I'm talking about. And I'll apply it and show you what I mean. So if a line is parallel to another side of the triangle, it splits the triangle proportionally. So what that means is if this line, now I can move this line back and forth, so I'm going to do that for a second. I want to see, I've got, well, my big shape is already, I can't move that. So I was going to try and move the line. But if I create another line, and I'll get rid of it in a second, but if I create this line and I move it back and forth, it's always going to split up the triangle proportionally, no matter whether it's here or down there. So it does not need to be in the middle. Which is kind of important as far as this stuff goes. So the thing that I could write out based on that property is that IN over LI, I should be able to say that that's proportional to the other side. So IN over LI should be proportional to ND over DS. So, I mean, it kind of looks like what you would think, and I think based off of the last section, you could have figured that out on your own. So it's pretty quick. So if I just show you a pretty basic example where you have to find Pn here, I should be able to say that LP over Pn is equal to MQ over Qn. And then I should be able to substitute some numbers in and, pretty much solve it. So 3 over Pn equals 2 over Qn, which is 5. So cross multiply, 3 times 5 is 15, equals 2 Pn divided by 2. So it looks like Pn is equal to 15 over 2, which is 7.5. So I'm just going to leave it as a fraction. Might as well. There's no reason to change it. And that's how you do something like that. So this property is actually a biconditional. So I should put a little note that it's a biconditional. Meaning that it works the other way around. So if you have a line that splits the triangle proportionally, then you know that the lines are going to be parallel. So if I look at an example like this one, I can verify that they're parallel, which essentially uses the converse of what we just stated up top. So I can go backwards. If I can show that these are proportional, then I'll know that the lines are parallel. So basically, if proportional, I can show that the lines are parallel. I just want to show kind of why we're doing what we're doing. So that's over on the side here. So I can do some math and show that that's true. Don't get scared by the fractions and stuff. It may be helpful to convert that 4 and 2/3 into an improper fraction. So I can say 4 times 3 is 12, plus 2 is 14. So that's 14/3. Might make the math a little easier. So I should be able to say that 12 over 4 is equal to 14 over 14/3. Hope I did this right. 4 times 3 is 12, plus 2 is 14 over 3. Yep. So I should be able to say that this is true. So you may be asking yourself, like, how do I do this part with the fraction? but dividing by a fraction is the same as multiplying by the reciprocal. So I should be able to say that that's 12 over 4 equals 14 times the reciprocal, which is 3 over 14. At that point, you can see the 14s cancel, and I know 12 divided by 4 is 3, and since 3 equals 3, the lines are parallel. That was a little quick. Go back. You can see it again. Maybe, it was a little fast the first time, but you can show that that's why that's true. So that's the first property in this section. Moving on, there's something called the two-transversal property. So I'll show you what the property is, how you can apply it. And there's actually a second example way down here. And if you want to do it and check your answer, you can. I'm only going to do the first one because I feel like that should be enough. But if you need to do another one, then go for it. So the two-transversal proportionality thing, that's what your book calls it. So it's just got a funny name, but I don't care that you know the name. I more, care that you can use it, which is pretty typical. This is also going to be a biconditional, so it goes both ways. So if you have lines that are parallel to other transversals, then they divide those proportionally. I'll say that again. If you have lines that are parallel to transversals, that means the transversals are split proportionally. Remember that a biconditional means it goes both ways, so let's take this arrow and make sure that we see that it goes both ways back and forth. So if lines are parallel to multiple transversals, then the transversals are split proportionally, and vice versa. If transversals are split proportionally, then the lines are parallel to the transversals. So just know that it goes both ways. That's all. I know you thought we were leaving biconditionals way back in, I don't know, chapter 2. You've left us for weeks, but no, it is still here. So I know you're very sad and disappointed. Sad face for biconditionals. No, they should be happy about biconditionals. We're happy. All right. Oh, I just got a text message. No, I won't check it. Don't worry. I'll finish your video. All right. So let's throw some letters on here and show why this would be true. That way you can see, how you would set it up, and then we'll do it this next example. So anyways, I don't know what to call this. So I'll use my name, B-R-I-A-N-W. All right. So all this is saying is that if the lines are parallel, so if I have a bunch of these parallel lines, then they're split proportionally. So I've shown 3 parallel lines in this example. You can have as many as you want. So I've got parallel, parallel, parallel. So the proportions that you could set up would be that BR over RI would be equal to AN over NW. So this property is used in city planning and stuff all the time. Anything with roads, when you have one that's sideways and one that's straight, you know that they're going to be proportionate to each other. So if you're planning that stuff out, it's kind of a good thing to know. Anyways, I got this example down here. Now remember, I have the answer right there. So you could check and try it and see if you get it right. And then if you didn't, then you can watch my explanation. And if not, then just skip it. So it says an artist used perspective to draw guidelines to help her sketch a row of parallel trees. So she just wants to make sure that she's got this right and that they're actually going to make the right sense as far as the perspective goes. So she's got to make sure that she, stops this stops LN, at the right point and draws the tree correctly. So let's set up a proportion based on the stuff that we have. So I can say, you can do this a couple different ways, but I think the easiest way is I have AB and KL. That's one of them. And then maybe I'll use, I need LN, so I'm going to use BD and LN, and I should be able to say that those are proportional. So I hope you can see the color that I used. I know the green is a little funny because it's grass, but so anyways, I should be able to say that 2.4 over 2.6 is equal to BD, which is whatever 1.4 plus 2.2 is over LN. So I can do that. So let's just add these together. So that's 2.4 over 2.6 equals what is it, 3.6? So now I can cross multiply. Some of you guys use the fish. A smiley. It's not that good of a fish. So anyways, 2.4 ln equals 2.6 times 3.6. And then we're good. So I don't know these numbers on top of my head. What do I look like, a calculator? So 2.6 times 3.6 is 9.36. Now I have to divide by 2.4. Divided by 2.4, and that's 3.9. ln equals 3.9. Now make sure you put a unit on it, or I'm going to throw something at you. Seriously, I will. I don't care if you're at home. I'll find you. You got to put units on your stuff. Don't be a chump like Lindsay. Anyways, so that's how you do that. Cool. So we're 2 for 3 right now. So we just got to do the last one. It's another proportionality equation that you can set up. So, realistically, when you're doing these examples, it's pretty much what you would think is proportional by looking at the picture. So I'll show you this last one. And again, it goes both ways. It's a biconditional. So I'll write that it's a biconditional. So basically what you got going on here is if you have a segment that's in this triangle and you happen to know that these two angles are congruent, then the two sides are going to be congruent as well. So to label the sides a little bit different than I've been doing before, just to show you that it can be done differently, I'll call this side A, I'll call this side B, this side C, and this side D. I just did that right-handed. I'm special. So anyways, I need to label these vertices. So let's call this A, and let's call this B. Also ready. So if you have, if a segment bisects an angle, so if you have a segment the resulting sides of the triangle, so the sides of the two triangles are proportional. Again, biconditional means it goes both ways, so take that arrow, make sure it goes both ways. So you have a segment that bisects an angle, the sides of the triangles are proportional. Basically, with the blue things that are labeled on the triangle, it's saying that A over D should equal B over C. Doesn't matter what letters you put. You could put smiley faces. You could make them into fish. Seriously, it doesn't matter. It literally could be a fish. Now I have A over D equals B over fish. Really doesn't matter. I have two examples down here. I will show you one of them so you can see what's up. The answers to the second one are also there, so if you get the first one wrong and you want to try another one, then go do that. But I'll do this last one and then we'll be good to go. And we'll actually apply this to some stuff when you come to class. So again, B, C, and C, D are what I need to solve for. So again, some of you guys, when you do your examples and your quizzes and your tests, you don't know just to, when you get the letter, make sure you plug it back in. So we are asked for segment lengths here. So at the end of the question, I'm going to make sure that I plug these back in and actually find what I'm being asked to find. So I should be able to set up the following proportion, that BA over BC is equal to AD over CD. So that means 12 over Z minus 4 is equal to 10 over Z over 2. And again, you're going to promise me that you don't get scared away because there's a fraction and a fraction. It's not that big of a deal. You cross multiply and you get 12 times Z over 2 equals 10 times Z minus 4, which 12Z over 2 is 6Z equals 10Z minus 40 after you distribute. If I move my 6Z and I move my 40, a little algebra, I should get 4Z equals 40. If you didn't follow that, find someone who knows Algebra 1 and they can help you. All I did is just move stuff to a different side of the equation. I divide by 4 and I get Z equals 10. Cool. So that means 10 minus 4 up here for this example. it would be 6. 10 divided by 2 for this one right here should be, what's 10 divided by 2? 5. Did I do this right? Well, I think when I wrote my answers over here, I must have forgotten to divide by 2 because this should actually equal 5. So sorry about that. Looks like I did that wrong. Hey, if you did this and you are coming to check the answers, I'm sorry if I messed that up on you. Cool. So I think that's it. If you have questions, come to class, put little stars in your notes or something to ask questions. If you got that one wrong, and it was not because of my error, then go try 14. But how do we do? 15 minutes.